This Zoom session is being brought to you by the fractal Horizon Forming. Okay, for today, 3.1 and 3.2, we will solve linear systems by graphing, by substitution, and elimination. Well, actually, we won't really solve that many linear systems by graphing because it's not a good way to solve a linear system. First, okay, what is a linear system? Well, they come in various sizes. A 2 by 2 linear system is of the form ax plus by equals e and cx plus dy equals f. It's two equations and two unknowns. A, B, C, D, E, and F are constant. We're to try and find what x and y equal. For example, x plus y equals 10, x minus y equals 4. Two numbers add to 10 and differ by 4. What are the numbers? Well, okay, 7 and 3 solve it. 7 plus 3 is 10, 7 minus 3 is 4. So 7 by 3 is the solution to this system. Now, if you graph x plus y equals 10, you get a straight line in the plane. If you graph x minus y equals 4, you get another straight line. These two lines meet, they intersect at a single point because, okay, and not surprisingly, the coordinates of that point are 7 by 3. So the intersection of lines corresponds to the solution of a linear system. Now here's another pair of lines. X plus y equals 10, x plus y equals 4. Now if you graph that, you get two parallel lines. And they do not intersect. In fact, there's no numbers x and y whose sum is 10 and also whose sum is 4. X plus y is trying to be two things at once. But it's not a politician, it's a number. So no solution exists. And parallel lines in the plane correspond to no solution of the system. All right, so that's another possibility. Intersecting lines, parallel lines. The third possibility is lines that overlap. Here's the equation x plus y equals 10. Here's the equation 2x plus 2y equals 20. These are equivalent equations, so they graph to the same line. Overlapping lines, so they intersect along their entire length. So there are many solutions. Now, okay, there's a potential confusion. The book might say there are infinitely many solutions. The trouble is there's an infinity involved with this system as well. Here, the solution, it would have to be thought of as at infinity. And here we can have to, and for this we consider infinitely many solutions. And I don't like bringing in the word infinity because it confuses people. And I've long ago lost track of the number of times that someone would have one of these systems like this and give the answer infinite solutions. And I have to write down, what do you mean? Solution at infinity or infinitely many? They are quite clearly not the same thing, although they do have certain similarities. Here the lines have the same slope, here the lines have the same slope. In this case, the lines have different slope, and that ensures that there's one and only one intersection point. Here there's no intersection or along the entire length. I prefer to just say many solutions because it causes less confusing ambiguity. So here we have three possibilities. Intersecting lines with one solution, parallel lines with no solution, overlapping lines with many solutions. So I prefer not to say. I have to repeat, do not say infinite solutions because that's ambiguity. And in mathematics, ambiguity is not your friend. It is your friend in love and war, but math, by contrast, has standards. We proceed. So here's some examples. Here's a point negative 4 by 3. Does it solve this system? 4x minus y equals 19, 3x plus 2y equals negative 6. Well, you check by substituting. You substitute negative 4 in for x here and here, 3 in for y here and here, and both equations have to work for both equations, otherwise it's not a solution. If you plug in 3 here, negative 4 here, and 3 here, you get negative 19, which checks. Plug in negative 4 here and a 3 here, you get negative 6, which checks. So yes, this number pair does indeed solve this linear system. Here we have 2 by negative 3. Does it solve x plus 2 equals a half x, 3x plus 2y equals 0? Okay, again, we substitute. We plug in a negative 3 in for y, plug in a 2 in for x, and the left side is negative 1. The right side is positive 1. So no, it does not fit this equation. So no. Now, 2 by negative 3 does fit the second equation. You plug it in, you get a 0, which checks, but it's not enough. They both have to fit. So the answer is no, this does not solve this system. Okay, that was simple enough.